Hello everyone, welcome back to my channel. So in this video we are going to learn about plane wave characteristics in lossy or good dielectric. Okay, so plane wave characteristics in lossy or good dielectric. So when wave is traveling in lossy or good dielectric, what are the plane wave characteristics we are going to study? If you are first time to my channel, please consider subscribing and hit the bell icon to get video notifications from my channel. So generally a lossy or good dielectric means, so it is a practical dielectric. Okay, so it is the case of practical dielectric. There is some conductivity. Okay, so some conductivity exists in lossy or good dielectric. Okay, so when there is some conductivity, then sigma is not equal to 0. So sigma is not equal to 0. So when there exists some conductivity, so therefore, and when there is some conductivity, then alpha is also not equal to 0. There is always attenuation. So when wave is traveling in good dielectric, so there is always attenuation when wave is traveling in lossy or good dielectric, because alpha is not equal to 0. Why alpha is not equal to 0? Because there is some conductivity. Okay, if conductivity value is 0, then alpha is equal to 0. Sigma is equal to 0, then alpha is equal to 0. If sigma is not equal to 0, then alpha is also not equal to 0. When alpha is not equal to 0, that is, there is some value of alpha, that is, alpha exists. So alpha exists means there is always attenuation, because alpha is attenuation constant. When attenuation constant exists in the case of EM wave, then there is always attenuation present in the medium. Okay, so the condition for lossy or good dielectric is sigma by omega epsilon is very much less than 1. So you just have to remember this. This is the condition. Okay, sigma by omega epsilon is very much less than 1. Okay, so this is the relationship between the medium parameters. Okay, now we'll see one by one. So gamma actual formula is j omega mu into sigma plus j omega epsilon. Okay, j omega epsilon. So this can be written as root of j omega mu into if you take j omega epsilon common, so j omega epsilon I am taking out, so it will be 1 plus rho by j omega epsilon. So this is j into j square, so j square I am writing out of the root, so root of j square becomes j. Omega into omega square, so out of the root it will be omega, root of mu epsilon into, okay, so what does this value become? So 1 plus sigma by j omega epsilon whole to the power of 1 by 2. Okay, so we know that sigma by omega epsilon value is very much less than 1. So from binomial theorem, 1 plus x whole power n, so mod x is less than 1, so this can be almost equal to, it can be written up to 2 terms as 1 plus nx. So 1 plus x power n can be written as 1 plus nx. Okay, from binomial theorem, when modulus x is less than 0. So this value is less than 0, so modulus of this value is also equal to sigma by omega epsilon. So modulus of x less than 1, this condition is satisfied. So 1 plus x whole power n can be written as 1 plus nx. So therefore gamma can be written as j omega into root of mu epsilon into 1 plus, okay, nx, that is sigma by 2j omega epsilon. Sigma by j omega epsilon into 1 by 2. So sigma by j omega epsilon into 1 by 2. 1 by 2 is this one. So n is 1 by 2 here. Okay, in the power you have, in the place of n it is 1 by 2. So 1 plus 1 by 2 into rho by j omega epsilon, you can write like this. So it is j omega root of mu epsilon into 1 minus j sigma by 2 omega epsilon, we can write. So here in this term I am multiplying with j and dividing with j. So j into j becomes j square. So j square is minus 1. Okay, so j sigma, so as j sigma I have written, and j into j is j square, 2 omega epsilon left over, so 2 omega epsilon I have written here. Okay, so therefore gamma is equal to, so j omega mu epsilon multiplied by 1 is j omega root mu epsilon. Okay, so plus into minus, minus, j into j is j square. Okay, j into j is j square, omega root mu epsilon into sigma divided by 2 omega epsilon. So gamma can be written as j omega root mu epsilon. So minus of j square is minus 1. So minus of minus 1 is plus, it will become. Okay, right, so sigma by 2 I am writing, sigma by 2, omega and omega gets cancelled off, root of mu by epsilon. Okay, so under root epsilon is there, so root epsilon by epsilon becomes 1 by root epsilon. So 1 by root epsilon into root mu, so it will be root of mu by epsilon. Okay, so this is the value of gamma. Once you got the value of gamma, so gamma is equal to alpha plus j beta. Okay, so this is the value of alpha because it is the real term, and this is the value of beta because it is the imaginary term. So alpha is equal to sigma by 2 root of mu by epsilon Nepper per meter. Okay, if you observe here, alpha is not equal to 0. That is what we have taken the condition. So alpha is not equal to 0. So this is the proof here. And similarly, beta is equal to omega into root of mu epsilon radian per meter. Okay, so these are the values of gamma, alpha and beta. Next, eta. Okay, third one, eta is root of j omega mu by sigma plus j omega, sigma plus j omega epsilon. Okay, so root of j omega mu into, so take j omega epsilon common, j omega epsilon if you take common, so it will be 1 plus sigma by j omega epsilon. Okay, so j omega gets cancelled off, so it will be root of mu by epsilon into 1 plus sigma by j omega epsilon into whole to the power of minus 1 by 2. So since root is in the denominator, so this value is in the denominator, so if you take upward it will become minus 1 by 2. Okay, same 1 plus nx. Okay, so 1 plus x whole power n can be written as 1 plus nx form. So eta is equal to root of mu by epsilon into 1 minus sigma by 2j omega epsilon. 2j omega epsilon. Okay, so eta is equal to root of mu by epsilon into 1 plus, so I am taking this minus as j square. Okay, so plus I am keeping, so I am writing it as j square. So again j square is minus 1, so plus into minus 1 is again minus only. J square into sigma by 2j omega epsilon. So 1j gets cancelled. So finally what you get is root of mu by epsilon into 1 plus j sigma by 2 omega epsilon. Okay, so this is the value of intrinsic impedance. So if you want to calculate theta n, So we know the value of tan theta from last tangent, it is sigma by omega epsilon. So if you want to calculate theta n is the angle of impedance, intrinsic impedance. So angle is given by tan inverse of, or tan theta n, if you want to calculate tan theta n only, right? Tan inverse of, okay, tan inverse of imaginary part is this one, sigma by 2 omega epsilon divided by real part is 1. So anyhow in both cases you will get root of mu by epsilon, so in both cases you will get cancelled. Okay, so when sigma by omega epsilon is very much less than 1, that is when theta is less than 1, tan n theta can be written as n tan theta, or tan inverse of n theta can be written as n into tan inverse of theta. So this can be written as 1 by 2 into tan inverse of sigma by omega epsilon. Okay, so 2 theta n is equal to tan inverse of sigma by omega epsilon, right? So tan 2 theta n is equal to sigma by omega epsilon. So this is equal to tan theta also from this equation. So therefore theta is equal to 2 theta n. This is the relationship between theta and theta n. Theta n is last tangent angle and theta n is the angle of intrinsic impedance. Okay, so this is in the case of good dielectric. Okay, so we have seen for perfect dielectric both values are equal to 0, yes or no? For free space also both values are equal to 0, but for good dielectric, so if you can find any one value, so the other value can be found by using this relationship. Okay, and remember that both values are not equal to 0. Not only this, alpha is also not equal to 0. So when alpha is not equal to 0, there is always some attenuation. So there is always attenuation. All the theoretical concepts which we have discussed here, we have proved by using the formulas also. Okay.